on inequalities, and the big, like the new piece, you have to put it in interval notation at the end. So we did all the linear ones and the compound ones Friday. Today we're looking at two other types. So the first is a quadratic. Did you guys do any of these in Algebra 2? I really don't. Maybe? Okay. I feel like some years you don't get that far, so you may or may not have seen this before. So we're going to start like it's a quadratic equation, which means we want to factor it. Make sure your x squared is positive first. If it were a negative, what could we do? Multiply by -1. When you multiply by a negative on the inequality, what happens? The inequality flips. Okay. So this we could factor using the easy method. Multiply to -12 and add to -1. Okay. So if you were just solving an equation right now, you would say x is 4 and x is -3. And I have a lot of people that are really tempted to look at this and say, okay, that means x has to be less than 4 and x has to be less than -3. But let me ask you a question. If I picked a number like -5, if you plug in -5, you get 25 plus 5 minus 12. Is that less than 0? No. So it doesn't work with the inequality to just say both of them get the less than. So here's what we're going to do. These are the numbers that make it equal 0. So there's two different ways of thinking about it, and I'm going to show you both. Usually the more popular way is to put those on a number line, just a really rough sketch. So I don't care about plotting all the exact points, but the -3 would have to come first and then the 4. All right. You can use your graphing calculator if you need to, but we should kind of know, what does a quadratic look like? A parabola. Graph it real quick. Make sure. If you go to your y equals, because we haven't talked about graphing quadratics yet this year. It's been a while since you've done that. Just do the original one. X squared minus x minus 12. Alright, and you should get a graph that looks like this. Is everybody seeing that? Is your calculator? If your calculators are doing something weird, that's from my stats class, and I think.
I gave my sickness to Lucy, and then Lucy gave it to me.
I got something. I didn't want this one. I think I gave it.
I gave it to the whole team.
You literally gave it to me.
I gave it to the whole team, and the whole team gave it back.
Yeah,
I'm feeling good.
Jay, I did have soap in the back of my car.
Alright. Is everybody's calculator showing up normal now? Alright, so what we're trying to decide, we want to know when this is less than 0. So less than 0, is that positive or negative? Negative. I'm asking when this graph is below the x-axis. This line represents when it equals 0. And so when you looked at your graph, you saw it was above. This is where it hits, drops down below, it hits again, and then it's back above. So if I want the portion where it was less than 0, that's where it was below the axis. So that was between -3 and 4. How do we know if they get parentheses or brackets? Equal to or not? These are not equal to, so we just put parentheses. So my solution is every number between -3 and 4. If you pick a number like 0 and plug it in, you get 0 minus 0 minus 12. -12 is less than 0, so it works. Is everybody okay by using the graph to decide? Let's try this. Why don't you guys try this one actually? So did you get 5 and -3 for the places where it hits the axis?
Yep.
Okay. Then when you looked at the graph, it looked the same. As long as it's a positive x squared, these are all just upward. Oh, that's really sad. Okay, upward facing parabola. And I asked where it was less than or equal to. So less than, that's below. What changes when I threw the equal to on there? Brackets. You have to, when you do integral notation, it does matter the order of these. It's starting to stopping. So you have to do the smaller number and then the larger number. All right, are those okay? Let's do another one. Example C. What changed? We have to do the slip and slide. So this would be x squared plus 5x minus 24. So multiply -24, add to +5. We need +8, -3. And then what do we have to do? Divide by 2. So 8 divided by 2 is 4. So when the 2 are come up, so you get 2x minus 3. Okay. So if you set these equal to 0, we're finding out where it hits the x-axis first. So we get -4 and +3/2. So those are like my points on the x-axis. Now when you look at the graph, what does it look like? Go off the original one, but it's still just parabola, isn't it? All of these look kind of the same. Okay, but our answer is different because this time I asked you where it was greater than 0. Greater than 0 means positive. Where is this thing above the axis? And it's actually twice on each of those ends. So to write that, we have to go small to large. This one's going forever in the negative direction. So what do we put for that? -infinity, comma, it stops when we get to -4. We said equal to, so the -4 gets a bracket. If we have more than one piece, we put a union symbol. It's just like a capital U in the middle. Then the next piece starts at +3/2, and it goes forever, so we put infinity, and the infinity always gets a parenthesis. Okay, so you do have to watch if you want the less than or the greater than on this, and we could have more than one section of our graph that works. Is that okay? Do we need more quadratics? So I'm going to go into the last type of inequality. Okay, these are different. Because if it were an equal to, what would you do first? Multiply that x plus 4 and get rid of the fraction. Absolutely. But here's the problem. Do you know if x plus 4 is positive or negative? No. And if you multiply by a negative, what has to happen? Flips the sign. So I don't know if I would flip the sign or not, so I can't do that. So when you have inequalities, you can't multiply by a variable. So here's what we're going to do instead. We are going to try to get a single fraction and then 0 on the other side. So I'm going to first subtract this 1 over. This is just like 1 over 1. If you wanted a common denominator, it has to have x plus 4, right? So I'm going to multiply this fraction by x plus 4 on top and bottom. What would I have to do with my negative now? Distribute, so it just runs through the top. So now we have a common denominator, we can make a single fraction. So 5 minus 4 is 1 minus x over x plus 4 is greater than or equal to 0. This is the setup I want. I have a fraction on one side, 0 on the other. So now, on this number line like we were doing, we're going to put what makes the top and the bottom 0. So what makes the top 0? 1. And for the bottom, -4. On these, you will need to graph them every time. There's no set rule about what they're going to look like. So we are going to graph this fraction right here. Make sure you put the top in parentheses and the bottom in parentheses. So go to your calculator. You want 1 minus x in parentheses divided by x plus 4. If you're having trouble getting the graph, let me know so I can help. So what I am ultimately trying to decide here is just if things are positive or negative. Right? So if I look at this first section of the graph, was this positive or negative? Positive is above the x-axis, negative is below the x-axis. So this part is negative. So my graph starts out negative. Okay. We haven't talked a lot about the graphs yet. This is what's called a vertical asymptote here. We'll get into that later. But really we need to know what happens between -4 and 1. My graph is above the x-axis, so that part is positive. And then what happens after 1? It goes negative again. We have negative, positive, negative. Caution you, most of the time it will alternate signs like this, but not always. So it is possible to have 2 positives in a row or 2 negatives in a row. All right, which ones did we want? We said greater than 0, so is that positive or negative? It's positive. So it's positive right here in the middle. Equal to means bracket, but if I write this, I am wrong. I don't even know why. I mean, it looks right. Everything between -4 and 1 gives me a positive. Equal to means bracket. What happens if you plug -4 into this? What do you get on top? 5 divided by 0. Can you divide by 0? No. So on these fractions, even if it has an equal to, the one that makes the denominator 0 has to get a parenthesis. So the -4 has to get a parenthesis because you can't have 0 on the bottom of a fraction. So these are a little more tricky. There's a few things we have to remember. We have to get it all on one side, get that common denominator, and we have to watch our parentheses at the end. Let's try another one. First step. You guys are doing it. What are you doing? Subtract over your 4. And then what do we need? We need to get a common denominator. So this is like a 4 over 1. So I'm going to multiply by x minus 3 on top and bottom. That gives us a 4x minus 12. Right, it's a subtraction, so I'm going to distribute my negative, and then we can put these together. So 6 plus 12 is 18 minus 4x over x minus 3, greater than or equal to 0. So if we set each of those equal to 0 to find the numbers, we get 9/2 or 4.5 and positive 3. When you graph it, you want to graph this last fraction we had.
Thanks.
Can you guys tell me what the sign would be on my graph? What's the first section? Negative, positive, negative. Which ones did I want? Greater than is positive. Can they both get brackets? No, the 3 cannot because it came from the bottom. So my answer is parentheses 3 comma 9/2 with a bracket. I want you guys to try one on your own. I'll kind of walk around, so if you do have some questions or you're having some issues with this, you can let me know. This is yours. Start by subtracting over your 5, multiply it by 3x plus 4 on top and bottom, distribute this negative. So 2x minus 15x is negative 13x, negative 1 minus 20 is negative 21. Alright, So now if we set the top and bottom to 0, we get x to be negative 21 over 13 and a negative 4/3. All right. So which one's smaller? Type them in and get a decimal if you don't know. So just divide them out. The negative 21 over 13. What's that as a decimal?
1.6.
I had this negative 1 minus 1.
We're on the same side. Yeah, I added the 21.
So you can put the negative on the top or the bottom. So this is like a negative 1.6 and that's like a negative 1.3. So this one's smaller. Don't use those decimals though for your final answer. We want the exact answer, so keep that fraction. Okay, then graph it and see what it looks like. Okay, so this is, I don't want you to think it's always the way. Our examples have all kind of turned out the same, the negative, positive, negative, but that's not always the case. Okay, so we do need to make sure we're checking. So this one, it starts out negative, then it jumps above the axis, and then drops back down below. Which ones did we ask for? Less than, so that's the negatives. We don't have to worry since there's no equal to, everything gets a parenthesis. So we have to describe both of these solutions. So this one is coming from negative infinity until we get to negative 21 over 13. Union, negative 4/3 positive infinity. How are we doing? I'm going to do one more, I think, just because sometimes the easier problems turn out to be harder because people overthink them. So let's try one. If I said let's do negative 5 over x minus 1. Let's just do this. What would you do first? We can move that fraction over. So if we subtract it, do I have to get a common denominator here? No, it already has one, so we can just put them together. Okay, we're used to setting the top and bottom equal to 0. Does the top ever equal 0? No, so we're not going to worry about it. What makes the bottom 0? 1. So it's okay if you don't have more than one point on your number line here. All right, so if I graph negative 8 over x minus 1. So before I get to negative 1, this graph is positive, and after it was negative. I asked for the greater than, so I asked you for the positives. Equal to means bracket. Can I put a bracket on the 1? No, because it makes the bottom 0. So my answer is just negative infinity to 1. So it's possible in these, you may not have to get a common denominator, It's possible that maybe this top is never going to equal 0, and you only have one number on your number line. So many of those scenarios can happen. Is this good? So let's add to the homework from Friday. So this will all be due tomorrow. Page 155. Okay, I'm adding 7